So really the only part that is left for us to discuss with this little sample that we had, and I'll just bring it back the way it was before I made my changes to the main method. Okay, so right now I have a compute result which could potentially throw an exception, and of course I also have the main method which uses the try and catch a series of calls, and I'd like to discuss now this finally block. So the finally block really is executed. Let's just start with the try block. The try block says that we're going to try some things. You can place there the code which is expected to throw some exceptions, but many of the lines of code may not necessarily throw an exception. However, depending how this workflow goes, at some point it may stop and cause an exception which will be likely caught by one of these catch statements. So some statements could then become unused by the try block. But at the same time, catch blocks clearly are also optional because they're invoked only when the specific exception is thrown, right? So catch blocks are optional. Parts of the try statement, try block, are also optional. However, this finally block is designed to always execute. So regardless whether there is an exception or no exception, the finally block always executes. And when we say always executes, it means that even if you have a return statement here, right next to this print line, and we can actually experiment with this, right? So even if I decided to exit from here and say return, place a return statement on every single branch of the code which precedes the finally block. If I now save this and run it, look what just happened in this specific example. I called compute result, which of course did generate the exception because one of the parameters is negative, and we check for the parameters to be only positive numbers. So this specific exception was thrown. So therefore, compute result did not complete successfully. And of course, we went over to catch the arithmetic range error, and we printed this error message, which is fine, right? But then we said return, which means like, okay, now it's time to get out of this method. But look what happened. We still printed something that belongs to the finally block. Okay, so this finally block contains a statement and typically would be used to clean up resources if there were any sort of dynamically allocated resources by the application. And that's the reason for the finally block to place some cleanup code inside that finally block, right? So I think I find it to be a little curious to just to say that the return statement here is obviously taking place when the execution gets to this return statement right here, but at the same time, before return is really physically made, this finally block still executes, and then we do indeed return. And we can prove that by saying maybe I think it could be an unreachable statement, but we can try it anyway. If one of these return statements, if I remove one of these return statements, then so here we can say that the end of main method is reached Okay, so we can print that. We can print that in our test. However, if we run it, right, if we save this and if we run it, you see that this statement is never printed. So what really happens is that compute result is invoked, that's fine, generates an exception is caught, the error message is printed, a return statement begins to execute, but notices that there's a final block executes, then the return statement continues on, right, and does return. So this message is never printed on this in this particular case. I just find this to be curious, and this is the behavior of the finally block in your Java try and catch statement. So just be aware of it. And of course, finally is optional, right? So finally is optional and should be used sparingly. The only true purpose of finally should be to handle situations related to dynamically allocated resources. So we can we'll probably see some more examples of this as we go through our presentation. So let's just go back to our presentation here. And so here it is. Any code contained in the finally block always executes, right? And I should make a note here that always executes if the try block begins to execute, right? So if I return, if I found a way to have an if-else statement which does not go through the try block, then the corresponding finally block will not execute. But if the try block is being, or try catch statement is now being executed and it has the finally block, then it will always execute. So it's good to know, right? And so it will execute regardless of whether an exception occurs or not, and the only time when it's not going to happen when you use system exit. If you use system exit, the nature of system exit is such that system exit never returns, and therefore you essentially leaving the context of your program entirely. And so when you say system exit, it never comes back. Basically, this is an immediate signal to remove your application from memory, and that's exactly what happens. Nothing else really does happen. Only the memory cleanup takes place, but no other application logic such as this finally block provides executes. So if no exception thrown in the try block, all catch blocks associated with the try block are ignored. All right. So the catch blocks are truly optional. If exception is thrown in a try block, then the remaining statements in the try block are ignored, and we proceed to a corresponding catch block. And if there is no corresponding exception handler in the catch block, we will have the situation with unhandled exception. And of course, the finally block is an optional block, and if it's present, then it will execute as we already discussed. The order of catch blocks is very important. We need to observe the hierarchy of exceptions. In our particular case, we're using a try statement with two catch blocks. One of them is trying to catch a custom exception that we've written on our own, basically just by creating a class that extends the exception class, which is part of the Java library. In this situation, what we do is that we place more specific type of exception earlier in a list of catch blocks, because if we try doing this the other way, we try try doing this the other way in this order. If we say catch, and then if we say catch exception, which is the superclass, and then catch another exception, which is a subclass, then because the subclass is always a kind of the superclass, then the compiler notices that and marks the statement as being unreachable, right? So it becomes an unreachable statement, the statement which cannot execute under any circumstances, and this is an error in Java. You cannot have, in Java, as far as the Java compiler is concerned, it doesn't like unreachable statements, right? So because of this order of the superclass and subclass, this will always be caught. This will not be caught because it will be preceded by this catch statement. Therefore, this creates an unreachable statement altogether, and this is an error in Java, and you're not allowed to do something like that. So let me bring it back the way it was, because otherwise, I mean, before I do that, let's just basically try building this application so that we can test what error message we get. Right. So here it says exception arithmetic range has already been caught. Right. So it just tells you that very specifically that there's a problem with the order of catch statements corresponding to these exceptions. So that's a clear signal that we need to go back to the way it was originally if we still want to keep this order. So we can do that, and then of course this will build fine. Okay, so this builds fine, and just close my file. Okay, so here this order is important.